So good afternoon, and thank you to iJOIN team for organizing this winter school. It's my pleasure to be here in Bremen and represent European project HARP, which indeed is a sister project to iJOIN. I am shared by two partners from this project. That's why I represent, in fact, two organizations, which is MTI Mobile, a company designing and manufacturing remote radio heads, and indeed Technical University of Denmark, which has very much network view and protocol view, architectural view. And it's not only me representing HARP over here, there's also my colleague, Matteo Artuso. Matteo, wave. So in this talk, we are going to have very much network-related view. And going through the base station evolution, we will see how the fronthaul network was evolving. And I will try to introduce you to what kind of enhancements did HARP introduce and what kind of optimizations are we proposing over there. And in this talk, we are very much going to be focused on why, not how. So at the beginning, in traditional base stations, well, this pink is kind of surprise, but in traditional base stations, there was no fronthaul link as such. You could see only antenna and then thick coaxial cables leading to the baseband unit. There was a problem with this architecture, mostly deployed for second generation micro base stations, that those cables were very lossy. That's why the separation, initial separation of the base station into remote radio head and the baseband unit. And you can see that the length of our coaxial cables is significantly shortened, where a radio head can be placed conveniently close to the antenna. And here the grandfather of fronthaul appeared, meaning the fiber connection between the remote radio head and the baseband unit. And this architecture was mostly deployed for third generation mobile networks. And it was optimized for the connection between rooftop and the basement. And keywords to remember from here is the CPRI protocol, which which is the most typical one used to organize the transport on the link between the remote radio head and the baseband unit. And on looking at Cloud Run, we are taking this architecture as a one step back, keeping in mind the delay requirements, keeping in mind the synchronization requirements. And the first original view on CRUN took into account the fronthaul network being a point-to-point connection between remote radio heads and aggregated, centralized, virtualized baseband units collected in virtual baseband unit pool. So keeping photographies in line, now we can imagine that there are still radio heads on the remote side. We can imagine a data center that really looked differently in my presentation. So sorry for the lower part of the picture. And then the fronthaul network emerges and right now spans on the metropolitan level. So when we talk about fronthaul for CRUN, it's no longer a link between the rooftop and the baseband, but it's a whole network segment covering metropolitan area. So what kind of implications does it give? First of all, we differentiate between the backhaul network and the fronthaul network, whether there are both point-to-point links or whole network itself covering different protocol solutions, protocol stacks. And what we are talking about here with the traditional functional splits is for the very typical LTE configuration, 20 megahertz, 2x2 MIMO, it's 2.5 gigabits of data, only to offer 150 megabits for users. So you can imagine what kind of volume of data are we talking for many sectors on one side, many sites, and that being aggregated over large geographical distances. Then there are similar constraints on the delay that we kept for the base station with remote radio head. The official requirement coming from standard is 8 milliseconds for HRQ process, the most stringent one. And then there are sources giving only 3 milliseconds internally for the base station. And as a base station, we right now mean a spanned base station, which giving different timing delays for processing both in baseband unit, both in radio heads. That leaves us for the transmission delay something in order of hundreds of microseconds. That's very much implementation dependent. What is the division of this delay budget? But those are the numbers cited by operators like China Mobile. At the same time, the data that comes through our fronthaul link needs to be very well aligned in time, meaning keeping the jitter below center amount, which is for example, MIMO 65 nanosecond. That means that if there are two radio heads connected to, there are two antennas connected to one radio head or several antennas connected to many radio heads, any of the two streams needs to be aligned in time within 65 nanoseconds. Radio head itself needs to emit signal in a very well-defined frequency. If you want a radio head to emit in 1 gigahertz, it needs to know the definition of 1 second very well. So the clocking needs to be delivered to the radio head with a great accuracy. And then there is a recommendation from CIPRI standard to keep the bit error rate on the fronthaul link on the order of 10 to minus 12. It depends on the application, but that's the recommendation for some of them, and this is the most stringent one. So bearing that in mind, one can think, okay, we are talking about cloudization of the world, we are talking about deploying Cloud Run, moving a lot of capabilities to the cloud. Now I would like to draw your attention that we need a whole network to support all those great ideas for Cloud Run. So how do we do that? The first discussion is about which medium to choose. And we can look at all of the available ones, whether it's microwave, fiber, but also copper. And keeping in mind the bit rate, which for sure is the greatest for fiber, but not that available. Still, half of the base station in the, or more than half of the base stations in the world are supplied by microwave connections. On the other hand, microwave works mostly on the short distances, so there is a lot of work in the research how to achieve greater speeds and greater bit error rates with microwave links. Fiber is seen as the most promising one for Cloud Run, although operators are not always have the access, good cheap access to good capacity of the fiber networks. For the copper, we are talking mostly up to 10 gigabits, so we can consider it as a kind of last meters in the building deployments, still with the newest technologies for the copper transmission. So all those three mediums can be used. And if we look at the bit rate, what could sound alarming for you is mostly 1 gigabit per second for the microwave connections. Of course, you can aggregate many links and as much bandwidth as possible. But most often, microwave is seen as combined with compression. So there are organizations working on compressions, and there are published solutions on compressions up to 3:1 ratio from Alcatel, from IDT. They are optimizing simply how the IQ data is generated on the fronthaul link. But there are also some newer ones taking into account different user activity, exploiting that. So not touching the functional split itself, but having some clever algorithms selecting only useful data. And other university work going up to 5:1 compression ratios. So my pictures disappeared. So now I need to improvise. So for the transport solutions, we can think about having fiber as a direct link. It's really surprising that my pictures are not there. For the microwave, we should consider mostly having baseband unit, then compression module, then we can use microwave, then another decompressing module, and a radio head. You can also aggregate traffic using wavelength division multiplexing. And you can also employ passive optical networks on top of that. So for the optical transport, you can add not only using direct point-to-point fiber links, but also aggregate them on the wavelength level. And you can also use OTN networks. There are standards specifying how to map OTN transport units, so map CPRI into OTN transport units. And that should be working. But what is not standardized yet is transmission between the baseband unit and the radio heads using Ethernet networks. So we are talking here about a few things: plain fiber connection, plain vanilla, microwave, possibly with compression, then WDM, OTN. And here the technology should be ready. Capacity not necessarily is out there. But what is very new and very hot in the industry is the discussion how to use Ethernet networks on the fronthaul links. I hope the rest of my pictures are there. So what is my personal motivation to look at this Ethernet transport on the fronthaul network is that it helps to maximize multiplexing gains. So one of the basic principles that Cloud Run exploits is that traffic is differently distributed in different types of the cells. Here we are on the university campus, and our cells are enjoying coverage and capacity from the base stations over here, while in our residential areas, the base stations are probably underutilized right now. So in the static assignment between the radio heads and the baseband units, there needs to be baseband capacity for whatever is the activity within the cell. In Cloud Run, we expected that aggregating the traffic from different cell types, like here we can see some office cell type with the peak of the traffic in the middle of the day, or a residential cell with the peak traffic in the end of the day. We expected that the amount of baseband resources is smaller. But what we concluded from simulations that it is around 1.5 times smaller in case of Cloud Run, but it also depends on which cell types do we connect. So you can see that we varied the amount of office cells out of office and residential split, and we concluded that the gain is maximum if we connect 30% of office cells and 70% of residential cells. So that opens a way to optimize fronthaul links and also overall cost of Cloud Run, and to minimize the cost of baseband resources if we could flexibly map different cells into different baseband unit pools, like yellow cells to the yellow baseband unit pool and red cells to red baseband unit pool. And that will be the best to do it dynamically. So Ethernet networks with its definitions for switching sounds here like an interesting option. And before we move into challenges of Ethernet, I need to draw your attention towards timing in mobile networks. And why it's really important? Well, if we want cells not to have interferences, we want antennas to emit signal in a very well-shaped bandwidth. And for that, we need very precise timing definition. If we want handover or TDD networks to work, they better be aligned in the specific time slots. But what can happen in the network between two devices is that, first of all, the definition of 1 second can be quite different. And you can see that the clock in the device B here is ticking at a different rate than in the device A. And what is worse is that those clocks can be shifted in time. And we don't want that. We don't want that to the extent of shift of 65 nanoseconds for MIMO. And we don't want the rate of the ticks of 1 second to be worse than 50 parts per billion emitted from a radio head. And what I mean by 50 parts per billion is 50 nanoseconds of the difference measured over 1 hour. Sorry, 50 nanoseconds over 150 million seconds. And there are various solutions to deliver timing that are used nowadays in the network. So if you plug in GPS to the remote radio head, we are pretty much fine. There is nanosecond accuracy, and you should be able to meet both of those requirements. Although for small cells, we may have difficulties in indoor coverage, so we may not want to use GPS. Also, because of the cost of ON-controlled oscillators and GPS modules, we may not want to have GPS in all of the small cells. That's why people are also using other solutions. Synchronous Ethernet can deliver good frequency synchronization. So with the nature of synchronous Ethernet, it delivers frequency. Timing, I mean, it delivers timing, meaning the ticks. There are packet-based solutions like 1588 version 2 protocol of IEEE, known also as precision time protocol. This one can deliver both the time of the day, so be able to align the start of the two timescales well, also the rate of ticking. And why am I bringing this topic up? Because traditional CPRI link, which can be applied to the basic version of Cloud Run, meaning point-to-point connections between the baseband unit pool and radio heads, this guy is already delivering timing information. So the common way of delivering, assuring good synchronization is to equip baseband unit with either GPS or 1588 or any other timing solution. And then Radiohead learns the time scale via CPRI protocol. It's synchronous protocol, and it's easy way for Radiohead and its oscillator to learn the timing. But if we want to introduce Ethernet-based fronthaul, we are spoiling that idyllic view. We expect to have switches in the network, and if you hear switches, then you may think about the delay. Not only the delay, but the variable delay. And you may recall that we are both limited by delay requirements and jitter requirements. So this starts to be a difficult topic. That's why we are looking at it in our project. We can try to use GPS or 1588, maybe some other solution. We may also think about consequences of different functional split, hence baseband unit pool ++ or Radiohead ++. So the challenge here is to transport the data which used to be transported over synchronous CPRI to put it on asynchronous Ethernet network for the benefit of switching, for the benefit of multiplexing, and also to simply reuse existing networks. So the idea is right now, as our fronthaul network is spanning over metropolitan area to aggregate these different types of cells, we may want to use existing networks for that purpose. And there is always a scarcity of fiber. That is a problem for many operators to deploy Cloud Run. So we're looking in the HARP project when actually it makes sense to use Cloud Run. Maybe we can combine Cloud Run with microwave, and when, and how to cut on the length of the fiber for all the deployments. And what we have done is, for example, via analytical calculations, we have checked what is the total cost of ownership of the mobile network if we connect some of the cells as Cloud Run cells with radio heads connected to the central baseband unit pool, while some of them as standalone all-in-one base stations, whether they are small cells or macro base stations. And we actually concluded that it all depends on the cost factor, meaning a ratio of cost of 1 kilometer of fiber deployment to the cost of baseband unit resources. And it sometimes may make sense to only deploy some of the cells as the ones connected to the baseband unit pool, meaning being part of Cloud Run solution, while some leaving them as standalone base stations, these traditional ones that I showed you at the very beginning of this talk. And it also depends on the coverage area, because we may need to provide more capacity in the dense deployments. So you can see that for the cost factor around 3, we start to see the benefit of deploying some of the cells as part of C-RAN. And that varies with the cost factor and the population density. We've been also looking at how to optimally assign cells to different baseband unit pools, because you may remember that delay constraints may limit us up to around 20 kilometers or a few kilometers of front haul span. So for the metropolitan area, we are probably talking about few baseband unit pools. It's not going to be one cloud serving it all. It's going to be few of them. So we're thinking, how do we maximize the multiplexing gain based on our conclusions on that, while at the same time cutting the cost of fiber length? And we've developed an integer linear programming model that can do it automatically. It can decide which cells should be connected to which pool. We've been also doing analytical studies, and you can find them in our publications, that some of the, for some of the base stations, it may be beneficial to deploy them as standalone base station and having microwave backhaul, and then join the fiber-based front haul of C-RAN, but as their backhaul. So we've been looking at when does it make sense to deploy base station using fiber, when using microwave, and due to the capacity constraints of the fiber of the microwave links, we concluded that it's sometimes beneficial just to leave them as distributed RAN and don't touch cloud technologies. So it's also good to have this critical view when to use cloud and when not, because it doesn't fit all solutions, although it sounds interesting. As one of the last points, I would like to share some updates from industry and where is industry going. So there are a lot of works on defining functional splits, and one of the main purposes is to reduce this big data rate coming from traditional functional split. There are different ideas being discussed right now, and I don't need to explain them here with all the presentations on the functional split that were already there. But what is the implication on the front haul link is that we may need to leave a very well-known CPRI protocol for that. CPRI by its definition is constant bit rate. So right now the data is just sent no matter if the users are active or not. And the considerations for the future protocol are to have it variable bit rate depending on the user activity. And also to increase the scalability. We may then be able to, with having some of the baseband resources present at the site and baseband unit pool being reduced of some of the baseband resources, we expect to have lower data rate, but also multiplexing of the traffic possibly on the links. Companies and standardization bodies are talking about the packet-based solution. So right now, CPRI, we can look at it more like circuit-based. We are moving towards packet-based. For load balancing, multi-point to multi-point connections is something that is to be considered. And also to have a fully standardized one, because CPRI right now leaves some of the room for vendor-dependent features. Why, for operators, it's definitely more beneficial to have it all standardized and then have different vendors competing for them when they can integrate baseband from one vendor and possibly radio head from another vendor. So who is looking at it? Well, there is a recently established task force within IEEE 1904.3. They are looking at mapping of IQ data over Ethernet. Very recently started, very active. So we can see here this trend going towards Ethernet. It's present. Then CPRI is hooking up with time-sensitive networking task, IEEE 802.1. Some people are talking about CPRI 2. Still, CPRI consortium maintains the original specification. And there has been also a proposal of study item for front haul that I've been just discussing, submitted to 3GPP. They don't have bandwidth right now to look at it, but there is activity. And you may want to call it work towards 5G. You may want to call it evolving 4G, but that doesn't really matter. No? Okay, so to wrap up, I wanted to draw your attention on the problems on the fronthaul link and the huge costs devoted with the capacity that we need to support all those great cloud ideas. And there is a trade-off between savings on the equipment and the costs of the network to support that, and that led to redefining the fronthaul. Looking at the base station architecture evolution, there was this traditional one with baseband and radio functions connected with the coaxial cable, which was then split between the RF part going to remote radio head and baseband part going to the baseband unit connected by fiber. More losses, better air cooling. And what is known is the Cloud Run architecture with some sort of links between radio heads. And at initial talks about Cloud Run, those were point-to-point links or some sort of aggregation. Now we are talking possibly evolving into fourth stage with having fronthaul network as an abstract term and all the possibilities for optimization and new solutions over there. So that will be it. If you are interested in hearing more of the literature overview, I can refer you to our new article published in IEEE Surveys and Tutorials Journal. It's a big survey article on Cloud Run, and we try to aggregate a lot of works done worldwide up to 2013. We cannot keep up with all the new publications emerging, so right now I'm not taking the challenge to aggregate them all, but this spoiled figure, again, I don't know why. It's coming from example from this one. So with that, I would like to thank you for your attention, and I will be happy to take your questions.
Thank you. So we have time for 2 atomic questions. Please fire away.
Yeah, do you actually have in heart any particular proposal how such a fronthaul network protocol would look like? Because that's a topic you also talked about. How would such a protocol look like? Because you have queues, you have jitter, you have.
So
do you have any particular proposal?
we would like to reuse existing Ethernet networks as they are, and that will be the best if we can take them as they are. That's why we are looking at the solution for synchronization itself. And our work focuses on synchronization, how to solve that between the baseband unit pool and radio heads. So we are not touching the IQ mapping itself. We believe that whatever you are going to conclude from projects like iJOIN on the split, this is going to be in our IQ samples, and fine, we would like to take it through the Internet network. And we take care of for that. Hmm?
You refer to existing Ethernet networks. Do you mean fiber-based Ethernet networks or copper cable Ethernet networks?
Well, with current functional split, we are talking mostly about fibers because we need gigabits of capacity.
Yeah, that leads me to the second part of the atomic question. If you say, fiber-based,
Yeah.
so then on the fiber you have a lot of bandwidth, so to say. So the bottleneck is your switching unit. Just for interest, what's preventing using passive optical switching techniques there?
It's also an option.
Or why? You have exclusive links, Radiohead to Cloud Run, and you're happy.
There is such an option. It was on my figure that wasn't visible, but you may see some of the remainings of that, meaning PON was somewhere there, WDM PON, that's the only thing that survived. So that's possible, absolutely. Although, to the best of my knowledge, Ethernet networks are more widely deployed. It's both via microwave or fiber links, but Ethernet networks are simply more widely exploited and will be cheaper for the switches, to the best of my knowledge.
Thank you very much, Aleksandra, again.
Thank you.